Hello everyone. Today we will see acid properties. What do acid properties mean in DBMS transaction? Acid properties are A for atomicity, C for consistency, I for isolation, D for durability. A, C, I, D. Remember this. Now we will see first property atomicity. The punchline for atomicity is all or nothing. We have seen a transaction's definition. We will again revise that a transaction is a sequence of operations performed as a single logical unit of work. It means it involves multiple operations, and if all those operations completed, then and then only we can say that transaction has completed. So this property is nothing but the atomicity. Atomicity ensures that it either happens completely or not at all. Why it is required? What is the importance of this is we can take a simple example of vending machine. Now we all like to take the food from the vending machine, just like this boy. Now this little boy, he has to enter the money into vending machine. He will select the packet whichever he wants. Then the machine will set accordingly and it will give him the packet to which he wants. If everything is fine, if all the steps work fine, then it is a happy kind of moment for him, right? But now suppose that little boy entered his money and selected the food also, selected the food packet also. But because as the machine was not working fine, the packet stuck over there inside the machine only, and his money is also inside the machine. This kind of situation not at all acceptable in real world or in DBMS as well, right? So what should be the right action if chips packet has not fallen from the machine? The machine should get refund to that boy, right? So that is what the atomicity is. The atomicity means if any of part of the transaction fails, the entire process has to be rolled back. The system should return to its original state as if the transaction never started, so that no data will be lost or money will be lost, right? This is very important property for the transaction. Now, after atomicity, the second property is consistency. So what consistency says that we will see. Consistency ensures that database should move from one valid state to another valid state after a transaction. What does it mean? That we will see with the example later. So how we achieve that always a valid state should be maintained. We can check it with the help of some rules and the constraints, and we'll try to maintain the integrity of the database. Okay, and the beginning also we will check, and after the transaction also we will check. If rules will be broken, then transaction has to be rolled back. We will see one simple example of money transfer transaction. Now here I want to transfer money from account A to account B. Account A's balance is 5,000. Account B's balance is 3,000. Now the addition of total of them is 8,000. Now we want to transfer 1,000 rupees from A to B. What is the consistency rules for bank transaction is? Total money should remain the same after the money transfer also, and balance should never be negative. So after the money transfer, again we will check the balance. Account A is having 4,000 now, account B is having 4,000, and total is 8,000. It means total is same. So it means that the database is again in the consistent state only after the transaction also. So that is a good means that is a good transaction. It means it is successfully completed, right? Now, after atomicity, we have seen consistency, and then next is isolation. Isolation means no interference. Isolation ensures that multiple transactions are running in one system, but it should execute independently. One transaction does not interfere with another transaction. The key idea behind this is it should look like, though in the concurrent environment they are, but it should look like they are executed one after the other. Means they are executing like a serial operations, even if they are in the concurrent environment. We'll see one real life example for ticket booking. Now, without isolation, suppose Ram and Priya both wants to book the seats. He's Ram and she's Priya. Now, only one seat is available, that is A1, and both have initiated the transaction at the same time. They both have seen that A1 is available and I want to book that seat. So both have selected the same time and they both have proceed. They both are trying to do the payment of it. If isolation is not there, then it may happen that both will book the same seat, which is not acceptable situation, right, in the ticket booking system. So what we want, that we want the behavior should like a serial execution, though it is a concurrent environment. So even when Ram has initiated the ticket booking for A1 set, A1 should get locked. It means that though the payment has not completed for A1, it has not booked by Ram yet, but still it is a locked resource because someone is trying to book that seat. So at that time, Priya will see that seats are not available. So sometimes it happens with us, na? In a moment, in seconds, the seats will gone in front of us, right? Railway reservation system. So few seconds before it was available, but now it is not available because someone has put locked on that. So that's a isolation, and we want isolation in the concurrent environment. So what we have seen: atomicity, consistency, isolation, and now the last property is durability. So durability means the changes must be stored permanently. So durability ensures that once a transaction is committed, its changes should be permanent in the system. Data should save after the crash also. It should remain safe. So we'll see that. Now suppose Alice has transferred 1000 rupees to Bob. Now it has stored that the Alice has transferred 1000 rupees to Bob, right? It has stored into the disk, commit has performed, and after the crash also, it should be there that Alice has transferred 1000 rupees to Bob, and whatever the Alice balance and Bob's balance should be there. Okay, because of the crash, it should not get erased. Data should remain safe, and then only we can say that that system is trustworthy, right? So these are the ACID properties, which is very important for the transactions. We will see quick recap of it: atomicity, all or nothing, transaction fully completes or roll back; consistency, valid state, data should remain correct before and after transaction; isolation, no interference should be there, transaction should not affect each other's execution; durability, permanent changes, committed data should never